Hi, and we're back. Okay, let's go for it. Last time we talked about these four different kinds of categorical statements. These are different kinds of categorical statements that you can put together to yield a conclusion. You can make valid arguments with these kinds of categorical statements. You can have two premises that logically entail a conclusion. So there's just four types of statements that we're dealing with. So it's not that much really to learn, right? You just have to know how to represent a universal affirmative statement, a statement of the form all S are P, right? Like all humans are mammals, right here. That's how we represent it. We're saying that if you are in the human group over here, and this is the mammal group, then there's nothing outside of the mammal group in terms of humans. All humans that exist in this circle also exist in this circle right here, right? The mammal group. So all SRP is represented like this to show that there's no members of the S group outside of the P group. If you want to say that no SRP, you can say, well, there's nothing in the overlap. There's no members of this group right here who are also members of this group. And we use the black to represent a lack of something, right? Just avoid death, barrenness, nothingness. Yeah. A particular affirmative is a statement that goes some SRP, and we interpret some in logic kind of in a weird way. It means at least one. There's at least one member in the particular, or in this group over here, the S group, who's also a member of the P group. Some SRP. Here, a particular negative is some S are not P. There's at least one member, maybe more, maybe lots more, right? But at least one member of the S group who is not in the P group over here. So some S are not P. Some S are P. All S are P, because they're all right there. No SRP, because there's none right there. Okay, so that's review. Get these in your head because you'll need to use them for the next part. Maybe you even take a picture of this on your phone right now so that when we go through the steps that are coming up next, you can quickly look at them as a reference point so you'll understand what I'm doing at each point. So maybe pause it, take a picture, have it ready to go on your phone. Okay, here we go. So we are now going to move on to the main part of all of this categorical logic before we move on to inductive reasoning and fallacies and other good stuff. We're going to finish up this thing this week. So let's go ahead and do it. You're going to learn what you just used, how to categorize categorical statements. Sorry, how to symbolize or represent or diagram categorical statements. You're going to use that knowledge to then learn how to evaluate arguments using categorical statements. So you learn how to use two circles, right, just two overlapping circles like that, to represent any of the four categorical statements that we looked at. And again, four, just four, get them in your head, right? Universal affirmative, universal negative, particular affirmative, particular negative. So use that same knowledge just to learn how to symbolize two statements all at once using three circles. Okay. And any of the arguments that we're going to look at in categorical logic, just to give you a heads up, they're all going to have only two premises, right? They're going to have two premises and a conclusion. So what you'll do is if you're dealing with a valid argument, you will symbolize the two premises, and then when you look at the whole thing, you will see the conclusion as well. It'll just be there, right? You didn't even have to plug it in. That's because once you've plugged in the premises, if you're dealing with a valid argument, the conclusion is already entailed. And in Venn diagrams, we can see that visually. We can see it directly how that works. It's because in a valid argument, you already know this hopefully, right, the conclusion's already always logically entailed by the premises. Remember, if the premises are true, then the conclusion must be true as well. That goes for all valid arguments. So with categorical logic, we're going to represent arguments We're going to represent the premises, and then we're going to see if the conclusion is there as well. Because if the argument is valid, the conclusion will just be there. Okay? So let's start just by symbolizing two statements separately. This is something we already did last time. This is just kind of review, but let's suppose we're dealing with two statements. All cars are vehicles. All vehicles are transporters. Transporting just something that can carry something from one place to another. I think that's probably true, that all vehicles are transporters. Of course, it doesn't have to be. We're just dealing with statements and how to represent them, right? So let's say we're dealing with those two statements and we want to be able to represent them. Well, first you have to ask yourself, what kind of categorical statement are these? What are they? Well, they're both the same, aren't they? You know, they're universal. They're saying something about all cars and all vehicles. And they're affirmative. They're saying something affirmative about them. They're saying all cars are vehicles and all vehicles are transporters. So they're both the same kind of statement. Right? They just happen to be. They're not always going to be like that in categorical logic. Right? These just both happen to be universal affirmatives. So now you can either go back to that screen that showed each of the four, wherever it was, or you can look at the picture that maybe you took, as I suggested, to know how to represent these. And this is what they're going to look like, because this is what all universal affirmative statements look like. Both of these are universal affirmative, so they're both going to look like that. Right now, it still says S and P just to indicate that this is the subject circle and this is the predicate circle, right? But we want to switch those out for the actual subject and predicate terms, so we can keep track of what we're talking about. So for cars, let's just make cars C, right? So this first is going to be all cars are vehicles, right? So we'll use a V for vehicles right there. So you see how this first one, this is basically just saying, not basically, it definitely is saying all cars are vehicles. This is just what we learned last time. It's just what a universal affirmative looks like when you put it in Venn diagram form. Got weird light stuff going on. V right here as well, because the first term of the next statement, all vehicles are transporters, it's the same, right? You see how they have a term in common? Now, all valid categorical logic arguments are going to have to be like that. If you ever see two premises in a categorical logic argument that don't have a term in common, it is invalid, right? So this is just impossible to do. All this stuff that we're going to do is impossible unless they have a term in common, right? So all cars are vehicles is right there. And second premise or second statement, all vehicles are transporters. And transporters will be T. So now we've symbolized both of our statements. Right? This here represents all cars are vehicles. This represents all vehicles are transporters. Now, what we want to do is somehow put both of these statements together into one big diagram. And I think you could see how that's possible, because look, we do have a V circle here and a V circle here. Maybe we can just put them together. So those two circles are the same, so we can just get rid of one of them when we put them all together. Right? We only need three circles. We're only talking about three groups of things: cars, vehicles, and transporters. So let's just use three circles. Just like that. So that's how we start. Anytime you start representing premises or trying to evaluate for validity, you start with this template, which is open. Right now, it's not saying anything. Vehicles is the term that both of the arguments, or both of the statements rather, have in common. So let's put that right at the top. Right? Again, all categorical logic arguments, if they're valid, they better have a term in common. And to indicate that they have it in common, we just put it right in the middle. Right? So always just look for whatever two premises, whatever two statements you're categorizing, just look for what they both have in common and put that right in the middle. Then let's label this one C to stand for cars. and this one T for transporters. Yeah. So now we want to represent the statement all cars are vehicles, right? We want to represent this up here. Right? You see how we got the C group, C circle and the V circle, C circle and V circle. So we just do the same thing, and we can just ignore the T circle. It doesn't matter. Right? Just, oh yeah. Circle, just black out all the parts of the circle that don't overlap with the V circle. Again, this is saying if you're a car at all, if you're in this circle that represents a circle around all the cars that exist, if you're a car, you're not over here, because there are no cars that are not vehicles. At least that's what the statement is saying. And so the statement is saying if you're a car, you're in here somewhere. And that this area right here is part of the vehicle circle. So we've successfully diagrammed this part of it. Now let's do the same thing for all vehicles or transporters. This is black out all the parts of the V circle that don't overlap with the T circle. So here's the overlap, so we want to black out everything else. Same way we just did for all cars or vehicles. And this is what we get. A weird kind of picture, but this picture has a lot of meaning. And hopefully you can see what it means. So now we've represented both of these statements into one big diagram. The diagram tells us both of these pieces of information. The diagram says all cars are vehicles, and it says all vehicles are transporters. But does the diagram tell us anything else? Here, I'm going to move to make the light less awkward. There we go. Does it tell us anything else? We have a statement about cars and vehicles, for sure, and we have a statement about vehicles and transporters. But what about a statement about cars and transporters? Does this tell us anything about the relationship between those two groups? Well, look at the C circle. This is saying that if there's any cars at all, they can only exist in this little white patch right here, this light patch. Everywhere else is death and nothingness. It can only be right here. Well, where is that? Yes, it's in the vehicle circle, like the first statement says, but it's also in the transporter circle. So can you be a member of the C circle outside of the T circle? No, it's all blacked out. This is the only area, right? So if you're a car, you're in the vehicle circle for sure. That's what this says. But if you're a car, you're also in the transporter circle, right? So the only part of the C circle that is not all blacked out to represent absence, complete absence, that also happens to be in the T circle. So if something is a vehicle, it must be a transporter. So we can conclude that if it's true that all cars are vehicles and all vehicles are transporters, then all cars must be transporters. Right? That statement just shows up on its own. It has to be a true statement as long as we're assuming that both these statements are true. So you can put both of these statements as premises and the statement we just discovered as a conclusion, and we know that this argument right here is valid. Right? Once you have this premise diagrammed and this premise diagrammed, then the conclusion just shows up. In other words, if this statement is true and this statement is true, then the conclusion is true as well. It logically follows. Right? If both of these are true, then the conclusion cannot be false. Right? So we've shown that this argument right here is valid just by representing the premises. Because once we represented the premises, the conclusion showed up all on its own. Again, all cars, right? This little white area, that's if you're a car, that's where you're at. you're going to have to be a vehicle and you're going to have to be a transporter. Okay, hope that makes sense. Let's do another one, obviously. Just one wouldn't be enough. Let's see if we can do the same kind of thing, right? We're going to try to do the same thing. Now we'll start with an actual argument, because that's what we're really interested in. Last time I started with just two statements and just to see if a conclusion would show up. This time we want to just do what we're really interested in, which is looking at a whole argument and seeing whether or not it's valid. And we're going to do the same thing, though, as we did last time. We just represent both of these statements right here into one big diagram, and then we'll see if the conclusion shows up, like it did last time. So start right away, start with the three circles, right? Because again, just count how many groups there are. There are cheaters, there are liars, and there's humans. 3 groups, 3 circles. If there were more groups, we would not be able to do any of this. Okay? Or if there were no groups in common, we wouldn't be able to do this. Right? So we're good though. We got 3 groups, 3 circles. And so we just want to represent those premises, those 2 statements. But to do that, let's first label all the circles so we know which group is which. So again, see what they both have in common, right? What term does this statement have in common with this statement? It's cheaters. In this case, it's the subject, and here it's the predicate. Regardless, it's what they have in common. So let's make the top middle circle cheaters. And we'll represent that with a C. Then the left circle, H, for humans. And the right, L, for liars. Now here's a little bit of something extra that you should always keep in mind. It's very easy to remember to put the middle term up here, but you might get confused as to which term you should put on the left bottom circle and the right bottom circle. And the answer is always just look at the conclusion. Right? The subject term of the conclusion should go here, and the predicate term of the conclusion should go here. If you go back and look, some humans are liars. That means humans should be at the bottom left, liars should be at the bottom right. Okay, so always remember that. The middle term, the one that they both have in common, the top circle, the middle circle, the subject term of the conclusion goes at the bottom left, the predicate term of the conclusion goes at the bottom right. Okay. Oh, I went a little too fast there. Okay. So yes, this is just reminding you, right? Left circle H, because the conclusion was all humans are liars. So humans, subject term, liars, predicate term right there. So now we've got the circles ready. We've got the groups labeled, so we know which circle represents which group or category of things. We've got all the cheaters here. We've got all the humans here. We've got all the liars right here. So then we want to represent these 2 statements. And again, these 2 statements are the premises of the conclusion. Sorry, the premises of the argument that we're evaluating. So let's do all cheaters are liars first. And it's a universal affirmative. Right? So you know how to do that, hopefully. Right? Or just look at your phone. Basically, we're looking at these 2 circles. Whenever you're symbolizing one of these statements, you can just ignore the other circle, most of the time anyway. So just concentrate on the cheater circle and the liar circle for this one. So everything in the C circle outside of the L circle needs to be blacked out, like that. So if you're a car, you're not anywhere. Sorry, we're not talking about cars anymore, are we? We're talking about cheaters. If you're a cheater, then you don't exist at all outside of this liar circle, right? If you're a cheater, you must be a liar as well. That's what the statement is saying. And then some humans are cheaters. We haven't done a particular yet. This is a particular affirmative. So for that, we'll look at the circles that we're dealing with. We're talking about humans and cheaters, and we're saying that at least one member of the group, human, is also a member of the group cheater. Right? So we have to put that X here. We can't put it here because that would mean that some humans are not cheaters. And we don't want to put it here because that would mean some humans are liars, which may be the case, but that's not what the statement says. The statement says specifically some humans are cheaters. So this is the only place where you can put that X to represent there's at least one member of the group or category human who is also a member of the group or category cheaters. So there we have it. We did the same thing. We represented both of the premises. And if this is a valid argument, then the conclusion will just already be there. We don't have to do anything else. So the conclusion was some humans are liars. Do we get that conclusion? Yeah, we do. Right here. This is telling us that there are some members of the group human who are also members of the group liar. And that X, of course, showed up because we're trying to say earlier, by representing this statement, some humans are cheaters, we have to put the X right there. We learned why. But it happens to be that if you put the X right here, you're also putting it in the liars statement, the liars group, rather. So just by representing the two premises, we got the conclusion to show up all on its own. Again, just look at the H circle and the L circle. This is telling us there's at least one member of the H circle, the human category, who is also a member of the L circle, the liar category. So that means some humans are liars. So if this premise is true and this premise is true, that conclusion is automatically true as well. Because once we've represented this premise using the diagram and we represent this premise using the diagram, the conclusion is there already. That's what valid arguments look like in categorical logic. If you have to do anything else, it means the argument is not valid. If the conclusion isn't just made explicitly clear, then it's not going to be a valid argument. Okay, so maybe let's have an example of that. See what that looks like. Say this is our argument. Hopefully you can tell just by your own logical intuition that this is not a good argument. Right? Even though the premises are true, we actually know independently that the conclusion is false, right? But let's see how this works. Let's prove it logically rather than just relying on intuitions. So again, how many categories, groups of things are there? Check that out first, because if it's not just 3, then we can't do this, right? Well, there's just 3: humans, fish, and cold-blooded creatures. So we should be able to do this with the 3 circles. 3 groups, 3 circles. So what do both of the premises have in common? What group or category of things? Humans. So let's put that right in the middle. Then, of course, to figure out what to put at the bottom, you just look to your conclusion. Right? I told you this previously, but again, just reminding you, what do you put at the bottom? Look at the conclusion. Put the subject term on the left bottom. And the predicate term of the conclusion at the right bottom. Okay, now we've symbolized all our groups. Now we just have to represent the individual statements, the premises. What were they? No humans are fish. No humans are cold-blooded creatures. Okay, so they're both universal negative statements. So again, if you have to look at your phone or go back to look at that chart for how to represent universal negative statements, you can do that. So let's say no humans or fish. How do we represent that? Like this. We're saying there's no members of the category humans who are also members of the category fish. There's no one inside the human circle who's also inside the fish circle. That's because no humans are fish. Right? I hope that makes sense. If you literally round up all the human beings, put them in a circle, then go look at fish, you're not going to find any humans there. All the humans will be inside the human circle. Fish will be in the fish circle, but we will not be in the fish circle. Do the same thing for no humans or cold-blooded creatures. So we're looking at H and C. We're looking at these two circles, and we're saying no members of this category are members of this category right here. So we want to do the same thing to say there's no overlap between the two. And this is what we end up with. Again, a cool little symbol, a diagram. It's full of meaning. It means at least two things, right? It means no humans or fish, represented over here, and it means no humans or cold-blooded creatures over there. Now the question is, does it mean no fish or cold-blooded creatures? Do we see the conclusion represented anywhere? Well, let's look at the fish circle. Certainly no fish are humans, that's true. But here, this overlap right here is not blacked out. So it's possible that there's an overlap. In fact, we know that there is, right? We know that actually all fish are cold-blooded. Maybe there's some exception to that. The point being, just by representing the premises, we did not get the conclusion to show up. This does not say no fish are cold-blooded creatures. In order for it to say that, this whole section would have to be blacked out to say that there's no overlap between fish and cold-blooded creatures. But we don't have that. This is wide open. There could be fish there. So this argument, since the conclusion does not show up on its own, the argument is invalid. Yeah. Okay, well, I hope that makes sense so far. We're going to go a little bit deeper into it. And what I'll probably do, because it's very difficult to create these arguments on this format, I'll probably just do a whiteboard thing again like I did with the exercises for propositional logic, so it'll be a little quicker and easier to follow. But these are just the basics right now. So hopefully this makes sense so far. All you're doing in each case is you're taking two categorical statements and you're seeing if the conclusion follows logically. All the premises that you're going to look at in categorical logic will be one of those four that we've looked at, and you'll know how to represent them just by looking at that chart. And once you've represented the premises, you just need to ask yourself, does the diagram also state the conclusion? If it does, then it's valid. If it doesn't, it's invalid. Okay, that's it for now. I'll probably add more to this before Wednesday, because we do have a bit to go through if we're going to finish all of categorical logic this week. And we're on a little bit of a tight schedule because of all the events. Of course, I'm making sure not to go too deep into the weeds for any of this. We did have to make some adjustments in those terms. But I am going to try to get through everything this week. Okay, so exercise, yeah, it's hard to do, hard to come up with an exercise for this because we really need to be drawing those Venn diagrams, and I'll come up with a way to do that maybe later, maybe when I do the whiteboard exercises with you. Maybe there's some way to do this. For now, I just want to know that you're watching this. I want to know if you have any questions about anything. I just want to know that you're engaged. This is one of those things where, you know, just like in class, you do the exercises because you showed up and you get credit for that. I'm doing the same sort of thing here, right? You watching these videos is you showing up to class. And if you're doing that, then I want to reward you for that with easy credit. So here, you know, I'm going to create a little thing like I did last time where you can submit something. And all I need you to submit is a sentence or two addressing this, right? You can also just say, yeah, I was here, I watched it. Or if you have questions or whatever it may be, you can do that too. All right, well, look at that. Just under 30 minutes, and the weird light thing is going on still. Let me say goodbye to you properly. Okay, bye, everyone. Hope you have a pleasant night, and I will see you again soon. Bye.